Welcome to 31, number 31. Will sodium nitrate be saturated, unsaturated, or supersaturated if 60 grams are placed in 100 grams of water at 40 degrees? So NaNO3 at 40 degrees Celsius. NaNO3 at 40 degrees will hold about 105 grams. So 60 grams will be under the line, and under the line is unsaturated. Anything under the line, this is the line. Anything under the line is unsaturated. Anything on the line is saturated. Anything over the line is supersaturated. Over the line, on the line, under the line. 60 grams at 40 degrees is way under the line. So that's unsaturated. An unsaturated solution of potassium chloride, KCl, at 80 degrees has 20 grams of solute dissolved in 100 grams of water. How many more grams of solute must be added to saturate the solution? Well, let's go to 80 degrees. We'll go up to our KCl line, and we see that it will hold 50 grams, right? We see that it will hold 50 grams, but we've only put in 20 grams. So how much more will it hold? 30 grams. 50 minus 20 equals 30 grams. Hope everybody sees that, where that line is. 80 grams. It'll hold 50. It already says we put in 20, so it'll hold 30 more. All right, name a compound that shows a decrease in solubility from 0 to 100. Explain why this occurs. Well, that's simple. I hope by now you've all figured that out. NH3, because it's a gas. And as temperature goes up, the solubility of a gas goes down. And that's my cat. Okay. We are jamming right out here. All right. Explain why a soda goes flat when it is left open for hours. Well, what happens to a soda when you leave it open for hours? The temperature goes up. And what happens to the solubility of a gas? When it goes flat, that means it's lost all its CO2. CO2 is gone. So the CO2 has gone down. So explain why a soda goes flat when it's left open for hours. So, because temp goes up, and as temp goes up, solubility of a gas goes down. In simple terms, because temp goes up, and as temp goes up, solubility of a gas goes down. So CO2 is escaping as we leave that can open, and as it heats up, all this CO2, the solubility is going down, so it's escaping. It's leaving the Coke. That's why hot Coke is terrible. Well, Coke is terrible anyway, but what is an electrolyte? An electrolyte is a solution made up of with an ionic compound dissolved in it. And ionic compounds break down into their ions. So which type of compound would you add to a solution to increase the conductivity? Ionic, that makes an electrolyte. Electrolytes are made up of ionic compounds. Hopefully I drew enough pictures on the board so that I don't have to draw too many more. Describe how the compound sugar is dissolved in water. Oh, draw and label a picture of the process. Okay, does it dissociate? Dissociation. No, it does not. So when I drop in a sugar, this is one molecule. When I drop it into water, all it does is sit there as one molecule. C6H12. H12O6. So let's say I had two molecules and they form a crystal together, C6H12O6. Well, what dissolving means is that those molecules separate from each other, C6H12O6. They just separate from each other, no longer in a crystalline form, in this nice orderly form. I dropped them into this vat of water, and so they separate, and that's what dissolving means. Now, when we drop a compound NaCl into water, it dissociates. That's an ionic compound. That's a metal. That's a nonmetal. So it dissociates. So I drop NaCl in, and this is my NaCl, and this is one molecule of it, and we're going to add another molecule that's attached to it. So the first thing is it dissolves, and then it dissociates. It turns into its ions, right? It separates out into its ions. So you have all these positive NAs and all these negative Cls, and they're all separate from each other. And this is dissociation, dissociation. It does dissolve at first. These separate from each other, and then it dissociates. So it does both. Would a covalent or ionic compound create more solute in a solution at the same molarity? All right, so I'm going to do both. All right, I'm going to drop just two molecules. Two molecules is the same molarity. So I have two molecules of MgCl3. And I have two molecules of it, so they're connected to each other. MgCl3. Right now it's a salt crystal. And then over here, I have two molecules of C6H12O6, a sugar. And I have two molecules of that, C6H12O6. All right, I drop them in the water. These separate from each other, but they don't separate into ions, do they? So you've got these two molecules that are floating around. When I drop these in, they dissociate, right? So I have magnesium, magnesium, and then how many chlorines? I have 6, 3 here, 3 here. So I have chlorine, 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 chlorine. 1, 2, 3, 4, 5, 6. Okay, would a covalent or ionic compound create more solute in a solution at the same molarity? Well, this creates 6 particles, right? And we know colligative properties are only affected by the concentration. So this is 6, and this is 2. So what do you think? Ionic compound? Covalent compound? It's definitely ionic. Ionic compound. It creates more solute in a solution because it dissociates. It turns into 2 or 3 times itself. Whereas this covalent compound just doesn't separate. It just separates from itself. It doesn't dissolve into all these different varieties of stuff. Okay, does the type or number of particles affect colligative properties? Okay, which question was that? Oh, here it is. Colligative properties depend on the concentration, which is the number of molecules, right? It's the amount of moles per liter that equals the concentration, the molarity, and not on the type. So, does type or number affect colligative properties? It's number of colligative properties. Number of particles affects colligative properties. Okay. If you want to add a gas to a liquid, what 2 things could be done to increase solvation? Now, we only talked about one. If I want to add a gas, okay, I'm going to flip this over really quick. If I want to add this gas to a liquid, what could I do to increase the solubility? Well, I could lower the temperature. The lower the temperature, the more solubility I have. So the first thing I'm going to do is lower the temp. The one thing we didn't talk about is you can increase the pressure. And I hope you understand why. If I increase the pressure on top of this liquid, if I have more pressure pushing this gas down, guess what? It's going to dissolve more readily into this liquid. That should just be common sense. Okay, last one. Now there's a lot of extra information in here, so I need to get down to what they're actually asking. They're saying if a person takes 2 tablespoons of vinegar, by the way, they define a tablespoon as 15 milliliters, so they're giving me 30 milliliters of vinegar a day, and the molarity of the vinegar is 0.84, so that I've got a molarity. How many grams of acetic acid will be consumed? Well, that seems like I just need to calculate moles, and the formula is 0.84 molar equals, and I have something in milliliters, but I can divide it by 1,000 and cause it to be liters, and I need X moles. That's what I need first, so 0.84 times 0.030, 0.84 times 0.030 equals 2.52 moles. So X equals 2.52 moles. Right? 0.84, 0.03, yep. Oh, 0.0252 moles. I knew I did something wrong there. Fat fingers on the calculator. 0.0252 moles. Okay, and now I just need to figure out how many grams that is. So we're going to do a dimensional analysis. 0.0252 moles of all this, HC2H3O2. And so I got to have units that cancel. 1 mole of HC2H3O2. And how many grams are in 1 mole of HC2H3O2? So let's calculate that. We have 2 carbons at 12 apiece plus 4 hydrogens plus 2 oxygens, which are 16 apiece. Enter. So I have 60 grams. So I need to do 0.0252 times 60 grams. It looks like I have equal to 1.51 grams. Do I have an answer? Oh, yes, I do. So I did a dimensional analysis. Sorry if I did that off camera. Figured out that I have 1.51 grams of, oh, I hate it. I didn't do my own units. HC2H3O2. And that is the entirety of the review.